they were talking about naming, and specifically polyatomic molecules. Because I know that a lot of you guys get confused, and it's really not that bad, I promise you. And so I wrote some of the most common polyatomic molecules on this video. For example, ammonia is an H3, ammonium is H4. So ammonia technically isn't a polyatomic, but what I wanted you to see, I know for me, at least when I was learning chemistry, I was like, how do I remember ammonia is an H3, ammonium is an H4? I don't know. Maybe you guys don't have that problem, but I did. So I realized that if it's NIA, that's 3, NIUM, that's 4. I don't know if that's going to help you, but that definitely helped me. But before I keep listing off the polyatomic molecules, I just wanted to say really quickly, please go to the top of this page, click follow, go to YouTube and click subscribe and help your girl out, because it takes time to create this content. Also on YouTube, I don't know if there was a confusion or something, but I just wanted to clarify. If you go on YouTube and you go to the playlist, each playlist is a folder and it has a class. So it's going to be, for example, chemistry, organic chemistry, biochemistry, anatomy, physiology, etc. So all of that is so that way you click on that folder and you have all my videos about that class, and it's going to make your studying much more efficient. So your girl is a pre-med student. I have a 4.0. Okay, so I definitely know what it takes to succeed in all these courses. And so I made videos on it, and I'm giving you my tips and tricks, so hopefully you'll succeed in your classes too. And if that interests you, please follow again. Jumping back, let's keep going over the polyatomic molecules. So you have hydronium, which is H3O+, hydroxide OH-, and yes, hydronium hydroxide is like the base of chemistry, especially when you go into organic chemistry. Like, you're going to see that a lot, so you need to get familiar and comfortable with it now. Mercury Hg2+, acetate C2H3O2-, azide N3-. So before I keep listing them off, I just wanted to say, usually if you have 8, think of it as a glutton. It's gonna be like another oxygen or an extra charge. Not always the case, but usually. So like here, if you check this out, so nitrate ends in 8 and it's O3. Nitrite is O2, so it has an extra oxygen, 8 more. And then you have cyanide, which is Cn-, and then thio. Anytime you see thio in chemistry, that means you have a sulfur, just hands down. Okay, then you go to carbonate and you have CO3 2-. So if you think about it, hydrogen is a positive 1 charge. So if you add, then you're gonna lower 1 charge. So instead of CO3 2-, you're gonna have HCO3-. And then you have chlorate. Again, it's a glutton, it's O3, and then chlorite is gonna be O2-. And then hypochlorite is even 1 less. Hypo means below, just for your common knowledge. And then you have dichromate, which I don't have a real way just to remember that one. I mean, obviously is 2 and for chromium, but that it has 7 oxygens. I'm not sure how you're going to remember that. If I come up with something, I'll let you guys know. Then you have phosphate, which is PO4 3-. And from there, you can realize that the charge drops. So like you add a hydrogen and it drops to 2-. You add an extra hydrogen and it drops to -. Now phosphite is going to be O3, and phosphate again is going to be O4, which is slightly different from in the past where you saw here like a nitrate it was O3 and nitrite it was O2, but it's the same principle that 8 has more oxygens. And then you have hydrogen sulfate. Again, it's O4. It's following the same kind of rule as phosphate. And then sulfite is O3. And lastly, you have oxalate. But now let's get into the actual naming. So I kind of wrote both. So I gave you a name to change it to a formula, and I gave you a formula to change it to a name. I kind of wanted to see my method. So check this out. So iron, we already know is a transition metal, and I did that on purpose. So we know it's going to be Fe, and then the charge is 3+. And then if you're like, oh, wait, I don't know what sulfate is. Okay, then you scroll up and you're like, okay, sulfate is SO₄ So I'm literally going to write SO4 and then 2-. And then I'm going to do the crisscross. This is extremely important, y'all. If you have a polyatomic, write it in parentheses. So that 2 is going to cross over here. 3 is going to cross over here. And so it's going to be Fe2, SO4, 3. That's it. Okay, now let's try another example. So in this, if you don't know if this is NH4, you're going to scroll up or check out whatever materials they give you, and you're like, oh, okay, that's ammonium. But where did they get that charge from? So let's see. If you have an NH4 and you have a 2 and the S, there's an imaginary 1 over here. So you're going to crisscross up, and that's going to give you the charges for each. So we know that this is a +1, and we know that this is a -2. So I know that it's going to be ammonium, because NH4, so that's what I'm going to write, ammonium. And then it's just sulfur, so it's going to be sulfide. Okay, let's go to the next one. So again, you have iron 2. So I'm going to write Fe, and I know it's going to be a 2+, and then phosphate. And it's like, oh, I don't remember. Then I go and check my material. You guys are going to have to probably learn this. If your professor allows you to have this, amazing. But eventually know that in chemistry, you're going to have to actually memorize these and not just scroll up like I'm doing right now. So again, you're going to do the crisscross rule. That 2 is going to go over here. The 3 is going to go over here. So it's going to be Fe3, and then PO4, and then 2. Don't do it in your head, guys, because you're going to make mistakes. And lastly, let's check this one out. So I'm going to rewrite it. You have Ca, and then NO3, and then 2. There's an imaginary 1 over here, so that one's going to go up. This 2 is going to go up. It's crisscrossing. I call it the crisscross rule. I don't know what like the official rule is called, but bear with me. So I know that it's going to be calcium. And it is not a transition, so I don't have to write like 2 in parentheses or something like that. And then I'm like, okay, this is NO3. I'm thinking it's going to be a nitrate, and yes, it is. So it's going to just be calcium nitrate. See, it wasn't that bad. If you guys enjoyed this video, again, please follow me here and on YouTube, and thanks again for watching.